This lesson is about one very confusing concept of mutability and immutability of some data type. If this idea is not clear, it can lead to different logical errors. Let me first show why I said that it can be very confusing. Let's discuss the concept for list and tuple. List is mutable while a tuple is immutable. In simple words, it means that a tuple once created cannot be changed while a list can be changed after we create that. So here we have a tuple. If I try to change this first element from 2 to 4, it will generate an error. But if it is a list, it will execute without any error. Now if I define an integer variable as a equal to 10, integer is also an immutable data type, meaning that we cannot change it once it is created. So does that mean I cannot change the value of a to 20? Actually, I can change that. So int is immutable data type, but I am able to change the value. The problem is what we get from this statement, that immutable data types cannot be changed after they are created. We will explore this in detail and will try to clear everything. Now let's see this piece of code. Here I have a user-defined function named as remove duplicate. It takes two lists as the input argument, and the requirement is to remove all elements from the list L1 which are present in the second list L2. For example, if these are the two lists, the result should be this list which removes 1 and 2 from the first list, since both of them are there in the second list as well. So here is the logic. We are iterating over the elements of the first list L1, then is the condition that if the element is in the list L2, we are removing that from the list L1. Let's run this and we get this output. 1 is removed but we see 2 is there. The reason is that we are removing the element from the list which is the same list as being used in the for loop. So when the first element which is 1 is removed from the list, 2 becomes the first element and 3 becomes the second element. So in the second iteration of the for loop, the second element of the list is 3 and not the 2, and hence 2 is never checked against the condition. Generally, we should not change the list inside the for loop on which we are applying the for loop. So what can be solution here? A typical solution can be creating a copy of the list L1 and use that in the for loop statement. So now there shouldn't be any problem because the list in the for loop is L3 and we are removing the elements from the list L1. Let's run this. But again we have the wrong result. And the reason is that a list is a mutable data type, and that's why I said that these can be very confusing and may lead to the logical errors. As you can see here, apparently we are doing everything fine, but we have the wrong result. To understand the mutability and immutability, we need to understand what happens at the back end when we define some variable. So let's discuss that from the very basics. Here if we have a variable a equal to 10, a variable has a name, for example a here, and we call it as identifier. Then it has a value which is 10 here, and that is also known as literal. This variable is defined in the memory, which means a slot in the memory is allocated for this variable and the value stored in there is 10. The memory location is identified by the identifier a, meaning that the identifier a creates a reference to the memory location, or you can say a is pointing to this memory location. Basically, a memory location has some address, but in program we access that using the identifier, for example a over here, and not by the address. Now if we make a equal to 20, we generally think that this value 10 will be changed to 20, but that's not correct. A equal to 10 created an integer object and integer is immutable. So when we say a equal to 20, that object in the memory with value 10 is not changed because that is immutable data type, but a new object is created and that has a value 20 and it will have a different address since it is a different memory location. And now the identifier a is referencing or pointing to this new object. Now if you are thinking what would happen to the first object, since no identifier is now referring to that, we will discuss that later in this video. There is a way we can verify what I just explained. We have a function named as id, which we can apply on any variable and it will return the memory address of that variable. So let's print the address of variable a before and after changing its value. So here you can see the two addresses are different. In your case, you would have different values here, but both will be different from each other for sure. And this verifies that the int object 10 is immutable. It was not changed, but a new object was created. Now let's see if we have this case where a variable b is defined with the same value as of a. Again, generally we think that we will have this kind of a situation, having two objects both having the value 10 and one is referenced by the identifier a and other with b. But in reality it is not like that. We have just one object as the value 10 and both the identifiers are pointing to that. And again, this is because int is immutable. Let's verify by printing the id of both a and b. And see carefully, both IDs are same. We know if I will print a equal b, it will print true because both have the same values. But we have another operator to check the equality, and that is by using the is operator. This operator between two variables actually checks if the two variables are same in the memory or not. We know a and b are referring to the same object in the memory, and hence it should also print as true. Now instead of integer object which is immutable, let's do the same thing for the list which is mutable. Both lists are having the same values. Let's first see the ID of the both lists. And this time the IDs are not same. So unlike immutable data type, here these are two different objects in the memory because list is mutable. Now let's see what will be the difference between equal and is operator. The equality check will return true because both lists are having the exact same values. But the is operator will return false because both of the lists are not the same object in the memory. Now let me change the list to a tuple which is immutable. And this time it is the same object. So that's one difference between mutable and immutable data type that you should know. Now let's see this case where variable b is assigned as a. You can easily guess that there will be one object in the memory and both a and b are referring to that. If at later stage I am changing the value of b to 5, it means a new object 5 will be created and b will be pointing to that now. But a is still pointing to the first object with the value 10. You can see initially both a and b have the same id, but after assigning a new value to b, the id is changed. Now let's see the similar scenario for the mutable data type list. We saw a while ago that if we will have another list with the same values, it will be a new object in the memory. But if we set the list b as equal to list a, instead of assigning the values manually, now it will be the same object. Now we have one list object and two identifiers a and b pointing to that. However, if we are assigning the values manually, even after the previous assignment of line number 2, now this b will be a new object. The point is, whenever we are creating the list by assigning the values directly, it will be a new object. But if we are assigning that to some existing object directly, then it will be the same object. Now let's see one very important behavior here. Here we know b is same object as a, but suppose I want to add another fourth element in the list b. So if I will do it like this, it is a new assignment and it means now b is different object. And if we print both a and b, you can see they have their own values. But if I add the fourth element by using the append method, and now let's see the values of a and b. And you will see that a has also been updated. Why is that so? Let's see it step by step. In first line, a defines a list object with elements 1, 2 and 3. In second line, b equal to a will point to the same object. So b is same as the object a, meaning that both a and b are pointing or referencing to the same object in the memory. Now the object is a list object which is mutable. It means that we can add, remove or change any of its element and the same object will mutate to a new form, and that is mutability. So here, when I will add the fourth element in the list object, while referencing that through b, that object will get a new element added into it without creating a new object. And the identifier a is pointing to that same object. Remember, all these methods we see on the list object, these will mutate the very same list object. For example, if I will remove the element 2 from the list B, you will see the effect on the list A, which basically is the same list object. You can also verify it by printing the IDs of the both lists, and it will be same. We also call it as B is alias of A. Now we know that we can get a slice of a list using the indices. And if I don't specify any of the index as start and a stop index, it means it will be the complete list slice. So it is the same as the list A, but this time it is not the same object. It actually creates a new object. List slicing always creates a new list without changing the original list. So here we can say that B is a copy of A, meaning that it has the same values, but it is a different object. And now if we change B or A, it will not affect the other. You can see 2 is not removed from the list A. And see here, these are two different objects. We can also verify this by using the is operator. Now if I come to this code, which we saw at the beginning of the lesson and could not get the desired result. Firstly, we were applying the for loop on the list L1 and mutating that list inside the for loop. That is causing the problem, so we thought to make a copy of L1 as L3 and then use that L3 in the for loop. But the problem was not solved because this L3 and L1 are the same objects. I hope you can very well guess now that if I assign L3 by list slicing of L1, it will be a new object and changing L1 will not affect L3. And now we have the correct result, where both 1 and 2 have been removed from the first list. One thing I forgot to mention is that these list methods mutates the original list without creating a new list, and so as is the case of changing some list element by the index. So if I change the first element to 10 in list B, it will be reflected on list A as well. Don't forget this important point that whenever we define the list with new assignment, it will be a new object. So now B is different from A. Even if I define B with the same values as of the A, it will be a different object. Now let's see the effect of mutability on user-defined function variables. We know the function variables are local variables, so x equal to 10 in the function has nothing to do with x equal to 20 of the main program. And if I want to create a connection between those, I will have to declare the function variable as global. Now if we have x as a list in the main program, and I can access that in the function following the LEGB rule, and I can mutate it over here, and the effect will be there in the main program x since it is the same object. So it means for this case I don't need to declare that variable as a global variable, and still I can mutate that list in the function. The input arguments of a function are also the local variables, and in case of list as input argument, you have to be extra careful. Suppose here the function has one list as the input argument named as A, and inside the function we are appending 100 into that. Now in main program, if I use this function and provide the list x of the main program as input argument, then that will be passed to the function as the input argument A. And here that will be same as x of the main program, although they have different names. So anything done on the input argument A will be reflected on x. You can see that here. This actually is very useful. Many times we want to process a list and update that, and we want to do that by creating a user-defined function. For example, if this list has many elements, in data science field when we collect some data, it is very likely that the data contains some values which are considered outliers, meaning those data values are far away from most of the dataset values. It is usually assumed that those values were collected wrongly and hence those must be removed or replaced. Usually the outliers are decided on the basis of the mean and the variance values of the dataset, but here for simplicity, I would say that if the data values are greater than 100 or negative, I want to consider those as outliers. And what I want is, I want to remove those and replace them by 0. So I will create a function for that. List A is the input list. I will iterate over the list, and if the value is an outlier, I will replace that by 0. I'm not returning anything. Let's apply the function on list X and print X after that. You can see the outliers were replaced by 0. So you can see the advantage here. You can define a function on list and then can apply that on any list, and that same list will get updated. However, if for some reason you want to keep the original list unchanged, you can easily do that by create copy of the list inside the function. Then update that copy and return that. Now the function is returning a list, so I should assign the output to some other variable. Let's print both x and y. You can see x is unchanged and we have the result in list y. Now let's see another effect of mutability where you need to be careful. I'm just writing here the difference between alias and the copy. Now suppose that I want to create a list of squares of the first 10 integers. We can do it in this way, where list is defined as empty list and then the squares are appended into that list. And we get that. Now instead of using the append method, I can use the list concatenation and can add a new list as square of I with the list A. And we get the same result. But there is a big difference between the two approaches. Let's check again the append method, and I will also print the ID of the list A in each iteration. And see that we have the same ID in each iteration, meaning that the same object A is being mutated in each iteration. Now let's check the other case of list concatenation and see carefully that these are different IDs, meaning that each time a new list object is created with list concatenation. And that is not an efficient way of doing this, since we are creating different objects for no use. Now here I will also mention what happens when all references to one objects are gone. For example, a equal to 10 and then a equal to 20 creates two objects, but there is no reference to the first object now. Python interpreter keeps the count of references to any object, that can be direct reference or the object used in some calculation or maybe in some function etc. And when the reference count of some objects becomes 0, it means that it is not being used in the program anymore, and then there is a mechanism initiated by the garbage collector. It will eventually delete the object and that memory will be free. So in this case, each time a new list A is created, and the previous list A will be deleted by the garbage collector by its own mechanism. So if you see carefully, you might find same IDs in these iterations as well. Why? Because when a new list A is created, the previous location of list A get free and might be used for the new list A. Now let's see if we have a list here having two integers and one inner list. The list A has some ID of course, but the list is the collection of objects which you can see, and those objects are also in the memory and hence they have their own IDs as well. I will print the ID of list A and of all of the elements of list A. See carefully that all these IDs are different. Now let's change the first element of the list from 1 to 5. I will print the IDs again. See, the IDs above and below the line are same except for the element A0 because that was changed. Now instead of changing the first element, I will change the last element, which is a list, and I will add one more value into that list. And this time you will see the ID of that element is not changed because that is a list which is mutable. The same object got mutated. Now let's change the list A to a tuple. A tuple is immutable. Again, here we have the ID of the tuple and for each of its element. Now if I will try to change the first element, it will generate the error because we cannot change a tuple. But if I will do this thing for the third element of the tuple, which is a list, there will not be any issue because tuple is not being changed here. Neither the elements of the tuples are being changed. They will remain the same object, but the third object itself is a list which is mutable and that is mutated but not changed to a new object. Now we will discuss one last thing, which is deep copy versus shallow copy. There is a way of creating the deep copy, and that is by using the function deep copy available in the module copy. This function will return a new copy of the list A. Suppose I have a nested list as list A. Since B is a deep copy of list A, so if I append another inner list in B, it will have no effect on the list A. Then in the module we have another type of copy function which is known as shallow copy, and the function name for this is simply copy. If we run this, you can see the same result, meaning that shallow copy is also a new copy. However, the difference is that a shallow copy creates a new copy, but the objects inside it will be the same as the objects of the original list. Let me show you that by the IDs. In case of deep copy, the ID of first element of A and first element of B is different, meaning that they are different objects. But in case of shallow copy, they have the same ID, meaning they are the same objects. So here B is different from A, but they hold the same objects. So when we are appending something in B, it has no effect on A since B is different object, but if I will append something in the first inner list, now you can see that 500 is appended in both list A and B because that first object in the both lists is the same object. If we had a deep copy here, there is no connection at all between list A and B. So that's all from this lesson. Thanks for watching.